Think about this. Imagine crossing the ocean by riding on a floating train under the water. Engineers are working to make this crazy idea a reality. Meet Kylie. She works as a mechanical engineer. A mechanical engineer designs, builds, and tests mechanical devices. Examples of mechanical devices include robot vacuum cleaners, elevators, and even bicycles. Kylie is currently working on designing a maglev train that will connect Los Angeles, California to Honolulu, Hawaii. This super fast train would make it much faster for goods to be shipped from the mainland United States to Hawaii instead of being transported on a boat. Even people could travel on the maglev train to get to the islands. Since there is no land that connects the mainland United States to Hawaii, the maglev train will travel through an underwater tunnel, kind of like those fish tank tunnels you can walk or ride through at the aquarium, but much bigger. Right now, there is an underwater tunnel for trains in Europe, but it is much shorter than this tunnel will be. Maglev stands for magnetic levitation. A maglev train uses electromagnets to make the train float above the tracks and to push the train forward. An electromagnet is made of a metal core, like iron, with a wire coiled around the core. Imagine an insulated copper wire wrapped around a nail. The nail would be the core. The core becomes magnetic when electricity passes through the coil. On a maglev train, there are electromagnets on the rails and on the bottom of the train. Magnetic repulsion between the rails and underside of the train cause the train to hover about 10 centimeters above the rails. The train uses a series of alternating attractive and repulsing magnets to move the train forward. Let's look at a typical workday for Kylie at her job as a mechanical engineer. When Kylie wakes up in the morning, she gets a text message from another engineer. The engineer wants her to explain the factors that affect the strength of electromagnets. Kylie explains that there are different factors that affect the strength of electromagnets. One factor that affects the strength of the electromagnet is the amount of electricity that runs through the coiled wire. More electricity makes a stronger electromagnet. The other factor is the number of wire coils that are wrapped around the metal core. The more coils there are, the stronger the electromagnet will be. When Kylie gets to work at 9 a.m., she meets with a couple of other engineers working on designing the underwater maglev train. The engineers talk about how the train will be about 2.5 miles under the surface of the water. A flight from Los Angeles to Honolulu is about 2,500 miles long. So the engineers discuss how the underwater tunnel will be around the same distance. That is about 80 times longer than the underwater railway that currently connects Britain and France. After her meeting, Kylie goes to her desk to work on making a list on her computer of the advantages of the underwater maglev train. On her list, she includes that maglev trains create less air pollution than traditional trains and aircrafts. They are also quieter. Maglev trains also cost less to maintain than traditional railways. This is because the trains don't actually touch the rails, so there is less wear and tear on both the rails and the train. In the afternoon, Kylie works with her colleague Pedro to solve a potential problem with the train. If the electricity to the electromagnets is cut, like during a power outage, the train would not be able to move. Or if the train is already moving at a high speed and the power goes out, it would probably crash. Kylie and Pedro brainstorm a few ideas on installing a backup power source so this doesn't happen. Around 4:30, Kylie writes out a list of things she needs to work on tomorrow, like figuring out where they will build the train stations and exactly how long the tunnel will be. While this will be one of the largest engineering projects Kylie has ever worked on, she is excited to build the first underwater tunnel for maglev trains. What two places would you want to connect with a maglev train if you could? Now it's your turn to go on an adventure and be a mechanical engineer.